Hello. So let's look into today's Leetcode problem, which is find champion 2. So here you are provided with n teams and these teams are numbered from 0 to n minus 1. And in the input, if you look into the edges array, we are also given with few subarrays here, which indicates this relative strength of teams. Let's look into this subarray first. So here this subarray indicates that 0 is stronger than 1. So the first element is stronger than second element. For this subarray, it will be the first element is stronger than second element, which is team 1 is stronger than team 2. Here team 0 is stronger than team 1. So these two inputs are given to us, the total number of teams, which is 3, and the relative strength of few teams as an input. So what you want to return for this question is the strongest team that you can find based on the input that is being provided. So another thing that they have mentioned here is the kind of graph that is going to get formed is directed acyclic graph. So you don't need to worry about any cyclic dependency over here, and the edges are all directed graphs. So that actually makes sense because 0 stronger than 1 means 1 can never be stronger than 0. It is always one way. So what you want to do is return the strongest team, and there could be few edge cases where you won't be able to determine the strongest team, and in such scenarios you will have to return -1. Let's actually look into one of the scenarios where you will be returning -1. Let's say team 0 is stronger than team 2, and in the other subarray as an edge as an input, 1 is stronger than team 2. So here you are not given with enough information, or this is the only information that you are given with. So for such scenarios, you can for sure say that 2 is the weakest team, but you can't say that 0 is the strongest team or 1 is the strongest team. So in such scenarios, you will be returning -1. And the question itself is, highlighting us to use some algorithm related to graph because they have mentioned it as a DAG. So let's leverage that. So by looking into this example or the examples given by them, you will come to an understanding that you will have to find an element which is not being set as the second element. So here you can see 1 is set as second element, 2 is set as second element, but 0 is never set as second element. So that means 0 should be the strongest team because it doesn't have an edge which is pointing towards it. That in other terms is called in degree. But here, yeah, okay, I didn't look into this example. So in this example, you can see the same example that I have drawn with different numbers. Here you can see that 0 doesn't have any edge towards itself, and 1 also doesn't have an edge which is towards itself. So in such scenarios you won't be able to determine which team is the strongest, so you will be returning -1. So if you look into the input array of edge, you can see that 2, 3 and 2. Basically 2 and 3 can never be the strongest element. So one thing that should come into your mind is to keep the track of elements which does not have any in degree. So for this example, 0 doesn't have any in degree and 1 doesn't have an in degree. Here 3 has an in degree of 1 and 2 has an in degree of 2. By in degree, what I mean is the total number of incoming edges. So you need to traverse the entire edges array and calculate the in degree for all the elements present, all the edges present, which indeed will give us in degree of all elements present. So what I have done here is I defined an in degree array of size n for n number of teams, and I iterate through the edges, and I simply increment the in degree of elements if it has an incoming edge. And then what I do is I iterate the in degree array and check if we find any node that has an in degree of 0, which could be a potential candidate for our strongest team. But if you find if you find more elements which has in degree of 0, which means that our decision might be indecisive. In such scenarios, we will be returning -1. Or if you find only one element that has a total count of 1, then you can definitely return that element. So the code is pretty straightforward. The only logic that you should be thinking about is the in degree logic. If you find an element that doesn't have any in degree, and in that group it should be the only element present, then you can say that the element is element or node or team is the strongest team. So that's pretty much it for the video. Thanks for watching. Bye bye.